Hello, everyone. I hope you all had a nice afternoon. And welcome to the second day of FUSIONCon. Woo, woo, woo! I'm Lorgene, pronouns he, him, his, and I'm a fourth year mechanical engineering major, second year transfer, and I'm the engineering director for Fusion. I want to thank you guys for going to the first day of FUSIONCon, and I hope you enjoyed it because this is another 4-hour session. Whoa! Our first event today is the RoboPupper Showcase. Oh, 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 oh. All right, so before we get into this, before we talk about the context of this event, I would first like to introduce the organizers. I already introduced myself, so if the advisor and the interns would like to do the same.
Great. Hello, my name's David Kopp. I'm an assistant professor of teaching in mechanical and aerospace engineering here at UCI. I've had the privilege of working with Lorgene over the last 2 years, I guess, on these competition projects. So I'm really excited to see what they came up with. This year was kind of a bummer. It was all remote. So I haven't gotten to see any of the things live in person. So I'm looking forward to the videos like the rest of you. Thanks, Lorgene.
All right, and if the interns would like to introduce themselves.
Hello, my name is Robert Boho. I'm a fourth year software engineering student. And I just want to know, I don't believe I selected that for my picture, but yeah, that is
Oh,
me.
you're welcome.
Okay, thank you.
Hello, my name is Alexandra Sanyan. I'm a first year CSE major, and I'm another intern from Lorgene.
Yes, thank you guys. So this engineering project program has been in Fusion for only just about 2 years, and Professor Kopp has been our advisor since it started. So I would like to show my appreciation with a thumbs up. And it would have been a hell of a lot harder organizing this program if it weren't for our interns. So I give you each a nod. All right, so a quick overview of the project. In fall quarter, 26 members were put into 4 teams and were tasked to make their own quadrupedal robots that resembled a dog to the best of their abilities. And that was it. The Stanford Pupper, which by the way inspired this entire project, credits to Colin for giving the idea. The Stanford Pupper project was a good starting point to guide the members since it was an open source project that provided pre-existing code and hardware and even instructions from the Stanford Pupper website. But generally, they still had all the creative freedom to approach this in any way they wanted to. And you get to see how they did in the past year, but not just yet. I still need to explain the rules, just bear with me. So this is the design restrictions. This year we had about a $1,500 budget for each team. And I know this sounds like a lot, and it is a lot. This was just the amount that we were funded from various sources. No team actually used up the entire funds, so rest assured we're not spending money too recklessly. Next point is that it must be reminiscent of a dog. This should be obvious, but I kind of wanted to see at least one of the teams breaking this rule by making an anteater or maybe even a giraffe, but I guess that's okay. And the last important one is having the ability to receive input from a keyboard or controller, or better yet, through their voice. And you get to see if they did that or not. And so here is the scoring system. There are 3 categories: features, presentation, and carry weight. The scores for the features were determined by balancing the difficulty to achieve them, how much they were emphasized by me throughout the year, and I guess impressibility. For example, having it move and walk was actually a lot more difficult than expected, so it's weighted more. Crawling and running isn't worth nearly as much because it is simply an extension of walking. And if you look at the bottom of the list, you can see the best feature set. You guys are going to vote which dog you like most in terms of their set of features. In the next category, the teams will be presenting, and you will be rating them on their presentation and robot design on a scale of 1 to 4. You can actually open up the voting form right now through this QR code or the link that I'll send in the chat. Yeah, and you could also type down the link that's written under the QR code if you're a masochist. The last category is carry weight, which is relative to the dog's weight. The values for the carry weight and dog weight were already put in the score system. So the teams got points between 5 to 20, depending on the rank. This category isn't worth much because it's not at all the focus of the showcase. One sec. If no one put it in here already. Okay. All right, just close your eyes while I get the link from this. Whoops. Oh, really? Okay, I didn't see. It's posted in there already. Okay. So if you guys are still with me, we're gonna now showcase the presentations. First, we have Team Hachiko, led by Aliana. I forgot I still need to give you guys rights, so I'm going to do that right now.
Yes, please.
Okay, now take it away.
Okay. Oh, start immediately now. Can y'all see my screen? Yes, yes. Okay, cool. Hello, my name is Aliana, and my team is Team Hachiko. We will be the first team to present today, so I hope you look forward to that. I'd like for y'all to meet the team. As I said, I'm Aliana. I am the team lead. I'm a 4th year mechanical engineering major, and please introduce yourselves.
Oh, hi, my name is Colin. I am a 4th year ME major.
And then 3rd mechanical team member. I split that team into 2, by the way, mechanical and electrical. But the 3rd mechanical team member is Angelina Lico. She's a 1st year mechanical engineering major. She's not here with us right now, but that is all right. Next is the electrical team. Introduce yourselves also.
Hi everyone, I'm Johnny and I am the 4th year computer engineering major.
And hello everyone, my name is Gabe Valena. I'm a 3rd year CS major.
And the 3rd electrical team member is Ariane Agno, 2nd year computer engineering major. She is also not with us, but it's all right. So next I'll be talking about the outline so you know what to expect of our presentation. First of all, I'll be talking about our design goals, showing our CAD design, talking about connecting and electrical components, showing the step-by-step of the manufacturing and assembly process, discuss voice and servo control, and then finally show our doggo and the video. So first of all, at the beginning of the year, we were told to do a few things, as Lord Jean said earlier. We were supposed to make a robot dog. It had to be mobile, meaning it had to move, of course. It had to be remote controlled, either by PS4 controller, Xbox controller, or simply by computer. It had to be autonomous, so you had to be able to see and detect objects to be able to avoid them. And lastly, it had to be voice controlled. So say if you want it to walk, you could simply tell it to walk and it walks towards you. You don't have to use a remote control. Next up will be Colin talking about our design.
Yeah, so our initial design was focused on 3 main areas. First, the leg design, then the frame design, and then how we're going to connect those components together and also all of the components inside each design. Next slide. So yeah, first off, the doggo leg. Each leg on the dog has 3 rotational degrees of freedom. That's pitch, yaw, and roll. And that leads to a total of 12 degrees of freedom for the entire dog. And one of the things about our leg design is that it required that all 3 servo motors necessary for those rotational degrees of freedom must be on the leg itself and separate from the frame so that it can rotate on its own and independently. So on the bottom there, you can see a couple pictures of our initial design, and you can see that the 2 servos there are housed in there in the leg. Now for the doggo frame, we put some time into this to ensure that one, all the electrical components had enough space on the robot so that we can add all of our components onto the frame. And so we can use our robot autonomously without any wires connected to laptops or anything like that. And also it needs to be able to support the legs of the robot and also make sure that the entire robot is structurally sound. We also used a modular design, as you can see. We have 3 different sort of like components to the frame. And that's mainly because of the space limitations from the 3D printers that we had to use. And yeah. So, oh, you want to go? All right. So one of the things that we tried to do for our robot was implement finite element analysis. That's so that we make sure that our robot is structurally sound. And initially, so our entire robot is 3D printed. So initially we had very thin 3D printed leg components. And we found through structural analysis that that doesn't make our robot sound. It means our robot fall apart, not our robot sound. So we decided to increase the thickness of our 3D printed legs after some analysis.
Next up, just gonna be talking about connecting components, or basically all the hardware. Here I've laid it out all for you. We've just used an assortment of screws and standoffs, a few different bearings for the joints and the hips of the pupper, threaded rods more for support of the legs, and not much to say about it, just showing y'all. Next is Gabe with the electrical components.
Right, thank you. So going more into the electrical components of the dog, we designed our robot around a Raspberry Pi 4, servos with a torque of 25 kg/cm, all connected to an Adafruit server hat. For voice recognition, we just use a normal USB mic. And for the Pi's power source, we used a Pi Sugar 2 Pro battery hat. And for the server hat, we had to use an additional power source. So we used a 7-volt LiPo battery, stepped down to 5 volts through a voltage regulator. And I will pass it back to Aliana for manufacturing.
Okay, back to me. This is detailing or summarizing sort of the manufacturing and assembly process. Everything was 3D printed. So up on the upper left is the 3D printer used. After that, first thing we had to do was assemble each leg, and that's what you see on the upper right and very right image. After that, we connect them to the frames. We lay them all out on end. At the lower left is the final assembly. You can see a better image of this later on, but that is the overall process.
So for the servo control, it was all based on our Adafruit servo hat, and they provided a tutorial which led to a library onto how we could control our servos. It's basically just a bunch of functions and protocols for us to be able to control the code using it. So what we did was that for basic commands and basic positioning for our pupper, like for it to sit, we had hard-coded angles, and all of these positionings were all controlled using our voice command. So for our voice control, it was also using another library called Voice Assistant, which utilizes Google's voice recognition software, kind of similar to OK Google. And what it used was a USB microphone. And from there, it detected certain keywords that the user would speak. From there, based on what they said from these keywords, it would lead to either a certain command, like to say for it to sit or for walk, or a conversation when they ask what time of day it is.
All right, so now that design choices are out of the way, now introducing, drum roll please. I'm assuming you're drum rolling, I don't know. Next slide, our doggo. Right, so if you want the juicy lore, we found him as an abandoned blind puppy and I've been nursing him back to health. I mean, clearly you could see he's blind and also you could see right through him, but it's okay. He's a very good boy following his favorite command to a T, stay. He's been doing it many times, sometimes even on his own. So it's great, it's just great. But we move on to the next slide. In all seriousness, we unfortunately weren't able to complete all the requirements due to time and other external factors throughout this very, very strange school year. But through the struggles and the power of marketing, we are ready to show off how much of a good boy he is. I hope you enjoy.
Before I share the video, let me stop sharing because I forgot to click to share my audio. So give me a minute. Okay, can y'all see? Can you please give me verbals?
Yeah, you're good.
Okay, cool. Sorry for the thumbnail, but here's the video. This is Hachiko V624. It is a robotic quadruped, product of Hachiko Corporation, released in the end of May and the first prototype of its line. It is made in the semblance of a dog. It is mobile, remote controlled, and has voice control capabilities. It can respond to human voice and act in kind. It's equipped with powerful digital servos capable of torques 25 kg/cm. It is controlled by a Raspberry Pi, one of the most powerful customizable microcontrollers out there, available to the public in local tech stores. A servo hat created by Adafruit is the motor driver used. It is capable of controlling up to 16 servos at a time. It utilizes a 2-joint leg structure with perfectly placed knee joints for optimum gait, making it capable of 12 degrees of motion. The traditional USB mic and audio jack speaker are used to provide the pup with its voice control and voice output capabilities. The design is roomy, simple, therefore very customizable. You can add whatever additional features you want. You want to see Hachiko in action? Well, let's not keep you waiting. Here you go. Hachiko can be used as a toy, as a loving pet, as a friend when you're alone in the park, or as a little helper around the house.
What? Where's my knife? Oh, thank you, Hachiko.
It is capable of quite a few things. It can stand, it can sit, it can stay.
Okay, boy, stay. Good boy.
Jump, wiggle its butt, play dead, it can swim.
Wait, no, he can't swim.
It can talk.
Hey boy, bark for me. Good boy. You want to go on a walk? Go to sleep for a little bit.
You can even have a quick conversation with it.
Hey, what time is it?
I think it's about time we play together again.
Do you want to play outside then?
No.
Why not?
There's a virus outside and I don't want to get sick.
I don't think you can get sick.
Still, I'm not vaccinated yet. They're only allowing mammals 12 years and up. I'm only a few days old.
Then do you want to play inside?
Sure.
What do you want to do?
Let's play hide and seek. Or do you have any new toys for me?
It's getting a bit late. Good night.
It is resistant to any and all terrains, including carpet, cement, grass, dirt road,
rocks, chairs, swings, grills,
underwater,
I said no!
Not convinced? Let's hear what our loyal customers have to say.
Hachiko has always been a super loyal dog to us. For me personally, even when I tell him to walk around, he always stands by my side, which I think means he's super loyal to me. So yeah.
I underestimate how great this dog is because it actually taught me patience. I ask him to stay, he stays. I ask him to jump, he stays. I ask him to move, he stays. But give it time and a little push, he finally moves. At first I was confused, but I see now that the real showcase were the tricks that he taught us along the way.
Buy now for only $9.99.99. And if you order in the next 7 hours, we'll throw in a free replacement pie in case you are unfortunate enough to accidentally fry it. Call 1-800-555-HACHIKO. That's 1-800-555-HACHIKO. Limited time offer, not available in stores, made in Irvine, California. Beware of imitators. May cause heart attack, stroke, and or death. Use with caution. Call 1-800-555-HACHIKO. That's 1-800-555-HACHIKO.
Yeah, that's our video. I hope y'all enjoyed. I can't really see what everyone is saying. The chat is not open, but before
All right,
we...
nice. Sorry.
You're gonna say something?
I mean, I was gonna transition, but if you had more to say.
Okay, a little more. Just before. No. Before we end off the presentation, just like to say a few closing remarks. And by that, just say a little bit of what we learned. I mean, doggos are complex and hard to build. It takes a lot of time, patience, research. If you don't know something, you really need to look it up. Personally, this is really the first time I've properly led a project team. It was a struggle keeping up with communication, being decisive, two of the many things I wasn't very good at. But it was a long year and I had fun. I definitely learned a few things. And do my teammates have anything to say?
Yeah, I could add on a little something. I pretty much share the same sentiment. Like, this was definitely one of the most challenging experiences, considering like none of us have never done a project this advanced before. So, it required a lot of research, and, given the year, just we didn't have like enough like time and resources to do that. But just the fact that we all persevered through the struggles, I'd say is pretty commemorative, and dare I say, pretty helpful in the real world. And along with that, I hope we all learned, something new that we may have not done with our major. Like, I know I've learned a lot more about electronics than I would have with my CS degree. So it was definitely a very rewarding experience.
Johnny, Colin?
Oh, Johnny, are you talking? No? Okay. Yeah, I'm just going to echo probably the same stuff that Gabe is saying. This was a really complicated project and a very tough time for all of us. So I'm just proud of what we ended up building, and I definitely think that I feel like we did as good as a team. So yeah.
For what I would say, as the person who worked on hand on this, as a computer engineering major, is as a fourth year who works on the Raspberry Pi in my coursework, I don't want to entirely say it's like the ultimate end goal for me to actually make embedded systems, but it's just overall good feeling that I work on the code and then in the end I get to see it work. It's even if it's just stuff I find online that other people has made, it's just incredible that I can make not even a big system, but something as small as this that can just respond to whatever I do. It's just overall fascinating.
Yeah. That is all from us. Thank you for listening to our presentation and video. I hope you enjoyed them, and I hope you enjoy the next teams, doggos, and presentations too. So yeah, that's all from us.
All right. Thank you, Team Hachiko. Oh, that was so good. All right, let's transition. I'm going to share my screen. Let's transition into the next team. Okay, okay. So this is Team Fido, led by Kelby Custodio. Yeah, go ahead and share your slides and video.
All right.
Oh shoot. Okay.
Hey, give me a second. Make sure I'm sharing noise too. Can you all see that now? Yes. Okay. So I'm just gonna go ahead and start us off. First of all, my name is Kelby Custodio. Thank you guys for being here. And I just wanted to introduce you guys to your new favorite quadrupedal, googly-eyed companion, meet Fido. So first off, before we get into our actual dog, I kind of want to introduce you to our amazing team. So like, as I said, I'm Kelby Custodio. I'm a 4th year mechanical engineering major. And I served as a team lead and as part of the mechanical team. And I think Chris is next.
Hi everyone, my name is Chris. I'm a 5th year aerospace and mechanical engineering major UCI. I was mainly responsible for mechanical components of the robot.
Hi guys, I'm Matthew McHenry. I'm a 2nd year mechanical engineering major. I was responsible for a lot of the housings and design of the structural components of the robot.
Hello. It is I, Robert E. Boho, yet again. And I was one of the programmers for Team Fido. I focused more on the basic design for movement and the external features that we added to the robot.
All right, hello everyone. I'm Devon Pineda. I'm a 1st year CSE major here at UCI, and I was mainly responsible with the programming of the robot as well.
Hi, my name is Sam. I'm a 4th year mechanical engineering major at UCI. I'm mainly responsible for the structure and also for the shipping process.
All right. Yep. Thank you guys. I'm gonna go ahead and go to the next slide. So as you guys saw earlier, we actually drew inspiration from the Stanford Pupper project. So this is Fido's parent pup right here. But Fido had big dreams. He wanted to be different and he wanted to do more. So let's show you guys just how we did that. So here are some reasons why we love Fido and why we think you should too. First of all, Fido is built different. Look at those legs. Our leg design is unique in that it utilizes a pulley system coupled with a timing belt and gears. This allows us to actuate the lower leg separately from the upper leg. The pulley moves the lower leg, while the upper leg is rotated by the attached gears. Both the upper and lower leg are independently capable of nearly 300 degrees of movement. I'm gonna go ahead and pass it off to Matthew to talk about the body.
All right, so for the body, we took a lot of inspiration from the Stanford Pupper project, with, as you can see, with like the carbon fiber plates and the general shape of the body. But where we changed some things were the main like beam components, or like the parts that are holding up the robot. We redesigned those from the ground up to have like these truss-like structures to provide a little bit more rigidity and allow cables to be passed through really easily. And then for the servo mount in the bottom left corner, we also redesigned that from scratch. We wanted to have the servos closer to the center of the body so that the weight distribution is closer to the center, which is another motivation for why we had the leg designed in the way that Kelby explained. So the top servo has a gear that is connected to that gear underneath that articulates the lower leg. And then the bottom servo is directly attached to the side of the top leg. So that controls that part.
All right, and lastly, I'll go ahead and wrap this slide up. While we did gain inspiration from the Stanford Pupper hardware, we went our own route in picking the internal components for Fido. Not only were the chosen components much easier to source, but they facilitated a modular design that enabled us to focus on specific subsystems of the robot at a time. So Stanford Pupper actually utilized a custom PCB, which centralized the servo control and the power, but we opted to use a servo driver and 2 separate power sources for both the Pi and the servos. We also chose servos strategically using a 25 kilogram per centimeter torque servo with 270 degrees of movement for the hip rotation, which requires less of a degree range. And we used a servo with a wider degree angle, which was the 300 you heard earlier, with a higher torque to power output and 20% lower weight for the leg actuation. All right, and second, Fido is a good boy. So I think Bobby and Devon will tell you about why he's a good boy.
Yes, yes, yes. We put so much time into coding that honestly, all I see or all I could read now is in binary. Pretty much, we started off with a very basic controller model view structure for how the robot interacts and puts in or works. But rather than view for a visual like a visual UI, you get the robot just performing its actions. Each individual leg, or for the model part, we took it as, or we wrote it in Python as it is in a Raspberry Pi and used servo drivers, which respectively needs their own they need their own API system for functionality. And over time, we kind of just thought, hey, you know what? Other than movement, how can we make it really special? So Devon, please take it away on how we made Fido such a great boy.
All right, now we added some extra features to Fido, which include a Twitter API called Tweepy and a weather API called OpenWeather. We learned how to use these APIs from scratch and how to apply for the Twitter developer platform to receive all its API features. With these two working together, we can tweet information such as high and low temperatures, the description of the weather, humidity, time of sunset, etc. for Irvines as well as other cities directly to Twitter. All right, back to Kelly.
All right, so yeah, I just wanted to wrap up this slide by saying we trained him ourselves. The software team worked really hard on coding him from scratch, and we all worked really hard on him, as you can see from these pictures. We met up a lot and we got closer throughout the process. Okay, and the last reason why we think you should like Fido is because he's just darn cute. I mean, like, look at those eyes. He's kind of clumsy, but that's cute. Got a great personality. He would welcome you home, I think. But why just tell you about it when we can show you? So we're gonna go ahead and play this video so you can see Fido in action. Also, let me know if the audio is working.
You've got a friend in me. You've got a friend in me. When the road looks rough ahead and you're miles and miles from your nice warm bed, you just remember what your old past said. Boy, you got a friend in me. Yeah, you got a friend in me.
This is Fido. He's a quadruped robot dog that is controlled via keyboard inputs. The Fido team has engineered him to be very stable and reliable. One of the most unique things about Fido are his legs, which are driven by 2 servos connected to a belt gear system that allow his upper and lower legs to move independently. Although he can sometimes be a bit clumsy, Fido is truly a robotics marvel. But don't take my word for it. Listen to these testimonials from satisfied customers.
With all the restrictions on campus due to the COVID-19 pandemic, I was really lonely until I met Fido. Constant update in Fido software and hardware make every day seem like a different adventure. Did you guys know he can tell the temperature now? I know I can always count on him to keep me company as long as I keep his battery charged, of course. Fido is truly the only pet and robot friend I'll ever need.
Fido can be a little clumsy sometimes, but that's what I like about him. Sometimes, once in a while, he throws a temper tantrum and he just kind of refuses to move. But I think it adds to his charm. Fido is always working to be a better dog. Always changing, always improving. What a dog, you know?
Hi, my name is Bobby.
I am a professional dog walker in Irvine, California, and I have to say, Fido changed my life. Every now and then, I would like to walk about 1 to 2 dogs a day, specifically my own, but I always keep ignoring the weather because the weather is so hard to figure out. And every so often, whenever I would walk my dogs, there'd be a thunderstorm in Irvine, California, and coincidentally, it would kill my dogs. But luckily, with Fido, he tweets the weather, and it's great. I get to see on Twitter what the weather is like, and I decide, oh, it's a good time to walk my dog. And you know what? It's about time now.
As you can see, the Fido team has created a great robot companion that many people enjoy having around. Thanks for watching.
All right. I did see that it was a little bit laggy, so like Fido said, I can link the video later. But, oops, I mean, that was pretty much it. Thank you guys for listening to our presentation. You know, just being here means a lot, and I think the team had a really good time working on the project. We learned a lot, and like as the previous team mentioned, it was difficult, you know, researching our own things and figuring things out on our own, especially with trying to create a different leg design. But I think we all did a good job, and I'm really proud of our team. And we even have plans to continue working on Fido after this project, just for fun. So yeah, I think that's all from me, but if anyone else from my team would like to say something, you can go ahead. Don't be shy. You guys speak a lot.
One thing that I want to add is that and every programmer for every other team kind of expects this too. Man, Raspberry Pis are built so different. It was so frustrating. I know I did the workshop on it and I was still lost. So, you know, for those of you who don't really know the programming process, I think it's better if you just think of it as magic, because we all kind of do at some point.
I would like to add something as well. Working on Fido, I would say all in all was a great experience for me. Being a first year CSE major, we really just focus on a really broad aspect of programming. So being able to apply it into something that I can see working was a really good experience. And I would love to continue to work on this robot beyond this project as well.
Let's actually wrap up. Thank you, Team Fido. For the sake of time, we're going to transition to the next team. But yes, you guys did a good job. Yes. Give me some claps.
Good job.
Yes. All right, now the next team is Team Golden Receiver, led by Maggie. You can go ahead and share your screen now.
JD. Hey everyone, in the midst of the pandemic, we had the incredible opportunity of designing and fabricating a quadrupedal robot dog with the guidance and generosity of Fusion and UROP. The interdisciplinary team was broken down into the mechanical, electrical, and programming team. Using principles from our engineering courses and the power of networking, we were able to get through our project challenges as a team. Golden Receiver is proud to present our pupper Gertrude. Now I pass it over to Chaz to give a brief overview of our presentation.
Thank you, Maggie. In this presentation, we will first introduce you to the team and then the puppet. Then we will continue with the mechanical, electrical, and programming specifications and conclude with some acknowledgements.
My name is Margaret Strong. My pronouns are she, hers, and hers. I am a third-year mechanical engineering major serving as the Golden Receivers team leader.
My name is Neil Cuizant. My pronouns are he, him, his. I'm a third-year mechanical engineering major, and I am the mechanical leg design co-lead with Cole.
My name is Chaz. I'm a third-year aerospace and material science major. My pronouns are he, him, his, and I worked on the chassis design in collaboration with JP.
My name is Kun. I'm a third-year aerospace engineering major. My pronouns are he, him, his, and I'm responsible for the web design with me.
Hello, my name is Alexandra Changian. I am a freshman studying computer science and engineering. My pronouns are she, her, hers, and I am the electrical lead as well as a programming assistant in the team.
My name is Aljon Veray, pronouns he, him, his. I'm a fourth year computer science major, and I was one of the programmers for the robot.
Hi everyone, my name is JD. I'm a first year mechanical engineering major. My pronouns are he, him, his, and I was part of the chassis mechanical team along with Chaz.
So to start off, we just wanted to share several pictures of our first prototype assembly meeting at an airplane hangar provided by Maggie.
The design was based on the Stanford Pupper, and here you can see some pictures of a prototype.
So, what's the use? Can't afford a personal assistant? No worries, because Gertrude has you covered. As you can see here, our dog is able to carry stuff on her back and be your companion. In addition, she's a guard dog with her chunky build. Lastly, no need to worry about training, food, stinky bath times, and even fur shedding. Gertrude is the perfect puppy for you.
Now presenting Gertrude the Golden Receiver. In this slide, you can see Gertrude's finished design. Next up, we got our promotional video adoption that showcases Gertrude's prototype.
JD, before you start that, can you move the panel? It's showing it's covering the slides. Thank you.
Have you ever wanted a dog but thought, it's such a hassle to take care of? Worry not, because we have a product just for you. Introducing Gertrude the Golden Receiver. Utilizing a new double leash feature, our prototype is able to dash with her legs from point A to point B. Here, we are using the single leash technique to support our prototype. Up next is a clip of Gertrude sitting and standing up. Doesn't she look so cute? And like I said earlier, Gertrude is able to carry stuff on her back. And even when Gertrude falls down, she knows how to stretch out her legs again. And don't forget to give your pupper some good pats and rubs. And did you know?
She make it clap, clap, clap. She make it clap, clap, clap. She make it. She make it clap, clap, clap. She make it clap, clap, clap. She make it clap.
In addition to clapping, Gertrude likes to pop and lock. And if your dog overheats, you can slap a pan on it and cook some good food.
This product is meant for educational purposes only. Power bench supply used to test the dog is not included. You are responsible for purchasing your own power source that supplies enough voltage and current. Please refer to the non-existent manual and production description slides and website for more information. We are not responsible for any smoke coming out of the motors or legs given and during usage of the product because of wrong battery selection. No other warranty is expressed or implied.
Here is a sample of the voice recognition function that we are going to implement in our final product.
Hello. Testing 1, 2, 3. Walk.
And we're done with the promotional video. Get your robot dog now before it sells out. We are the leading competitor of Boston Dynamics. Now, back to the slides for some more technical information.
So the final chassis length from the front plate to the tip of the tail came in at 356.6 millimeters with a width of 104 millimeters and a height of 168.59 millimeters, including the ears. The bottom plate itself measures 7.5 millimeters in height, which provided ample resistance to deflection during assembly and testing. The chassis itself weighs around half a kilogram and was printed at 30% infill to minimize weight and thus power required from movement. The power bank, which is used to power the Raspberry Pi, is located in the top plate slot with a groove to access the interface and includes a hole for cable management. The servos and Maestro are powered by the lithium-ion battery pack, which is housed in the holder located on the bottom plate to keep a low center of gravity. The battery holder also incorporates venting to reduce the possibility of the battery overheating, and the wires are fed through the hole in front of the holder. The final assembly was held together by threaded inserts located in the inner supports and bolts that secure the plates and battery holder to them. The ears on the top plate function as the IR sensor housing with a removable cover that is also secured using threaded inserts and bolts. I will now pass the presentation to the leg design.
Since our pupper is large, the legs have to be big and long to fit the body as well as strong enough to withstand overall weight. The legs consist of three main components: the upper leg, the lower leg, and the rod. The legs are 3D printed to reduce the weight as much as we want them to, and I personally add some curvature on the side of the legs so they have more strength and look more organic. The upper leg is 120 millimeters in length, the lower leg 161 millimeters in length, and when they combine, the pupper can stand as high as 208 millimeters from the ground. Taking into account the weight of the rod, we have an overweight of 86 grams for one complete leg. Now I pass on to Neil.
So each leg uses 3 digital servo motors with 25 kilogram per centimeter rated stall torque at 6.8 volts, housed in 2 3D printed hip brackets, which are connected by 2 standoffs. The lower leg is controlled by a threaded rod that's connected to the outer horn, and the upper leg is connected directly to the inner horn. A third vertical motor utilizes a disc to simulate hip rotation. The lower leg maximum angle displacement from resting position is approximately 70 degrees, and the upper leg maximum angle displacement from resting position is around 60 degrees. And consistent manipulation of both angles allows the pupper to achieve a wide variety of positions and gaits. Each leg can withstand at most 8.5 pound force in its default standing position, where the upper leg angle is 29 degrees and the lower leg angle is 93 degrees relative to that. And we'll now transition over to the electrical aspect with Alex.
The electronics in Gertrude consists of 2 microcontrollers and 3 sensors. For the main microcontroller, this is the brain of our dog, we have a Raspberry Pi 4 Model B, powered by a portable battery that controls the various sensors that we use in our robot. Then we have the Pololu Maestro Mini 12-channel microcontroller, powered by a lithium RC battery that controls the 12 servos that we use for movement. To exercise some caution, we integrated an RC back converter between the servo power line and the battery. Both microcontrollers communicate between each other via TTL serial communication protocol. In the image at your left, you can see a level shifter with a rainbow of color wires that goes from the Maestro to the Pi. Gertrude's list of sensors includes a 9-axis IMU, which gives you the dog angle and direction, IR sensors used for obstacle avoidance, and an USB mic that parses sound for speech recognition. Additionally, Gertrude includes a camera that displays in real-time video to your computer. Here is an electrical layout of Gertrude. At the bottom right, we got the Pi and its pinout that connects to the USB mic, camera, IR sensors, IMU, and Adafruit level shifter. Following the wires from the level shifter, we got the Maestro control module that connects to 12 servos. The Maestro then is powered by an RC battery, regulated by a back converter. Now we will shift to the software aspect of Gertrude.
The way our dog moves is with the Maestro Control Center software, a GUI designed for simple motor control through the Maestro microcontroller. The way we made the movement for the dog was as follows. First, we manually controlled the motors into the right positions for the motion we wanted. Then we saved the frame of animation of these positions into a sequence group. We repeated this process for each part of the movement we wanted. For example, the walking motion was 4 frames. Each frame lasted 200 milliseconds, but we had to manually adjust the frames ourselves. Lastly, we saved the sequence as a script saved within the Maestro itself. We plan to call these sequence scripts to the Raspberry Pi 4. In our test, there was data coming back from the Maestro through the script, but at the time it was not able to control the motors. The primary script allows for both text-based and voice control commands. However, this was also not used in the current build because it cannot communicate with the motors at the moment. So as you can see, the sliders here are used to control the motors individually, all 12 of them. It's worth noting that at the value shown, all the legs were in the same real-world positions. The frames were then saved into a sequence, and finally they were saved into the script on the right. The main script had text-based commands that have controlled the motion sequences and would stop them at a given input. For example, typing walk to walk, then pressing enter to stop walking. The speech recognition came from Mozilla's open source deep speech API, and that was integrated into the script as well. Here's an example of the walking motion on the dog stand. I'll pass it on to Maggie for a few more details about the robot dog.
Now learning all that, here are some fun facts about Gertrude. Gertrude makes good use of her short spine syndrome for better stability. Her whole body is composed of 90% PLA. Her ears are IR sensors, resembles the AT-AT shown on the right. And lastly, her good features won't be complete with with custom sneakers called shape-ups. And with the good, there comes the bad. Unfortunately, she developed rheumatoid arthritis and can't move like she used to. She loves food and now has a big belly where we store her power supply. Good thing is that she is still learning to moderate her metabolism so that she can take better, longer walks without feeling so winded. Because of how challenging but exciting this project has been and the friendship we have made, we look forward to continuing this project over the summer. Thank you again, Fusion, Europe, Professor Kopp, and Lord Jean for your guidance, and for all of you for allowing us to present our wonderful project. Thank you. 3, 2, 1. Thank you.
Thank you.
Awesome. All right. Thank you, team Golden Receiver. Woo! That was so good. Okay. Next team, we have what was it? We have, last but not least, Team Bolt, led by Cameron. You can go ahead and share your screen.
I can't hear Cameron.
Oh, still can't hear you.
Hello, can you hear me now?
Yes, you're good.
Yeah.
Sweet. Okay. All right, yeah. So as I was saying, we pre-recorded everything just to kind of, keep things in time. So let's go ahead and get it started. All right. Hi there, everyone. This is our Team Bolt Robot K9 project presentation, and we're just going to kind of go over all the work and all the stuff we've done in the past 3 quarters and kind of the culmination of all of that work and effort. But let's jump right in, and I'm going to pass it off to Sam.
So our objective is to explore the general application of a low-cost robot K9 and to focus on the mechanical quality and technical usability of it, as well as creating a cost-efficient design that is effective in a variety of different situations. I'll pass it on to Raniel for the purpose and goal.
So the purpose of the project is to explore the feasibility of an extremely low-cost robot K9 for the implications of accessibility outside of the large budget operations, The goal is to make an impact in the general field by asserting the replicability and affordability of such a project by any individual or small team. With that, I'm going to talk briefly about the cost breakdown. The cost of tools being like $165, the cost of the parts $320, and the overall cost being $47. And I'm going to pass it on to Cameron to talk more about the design.
All right, and kind of for our design inspiration, we were initially given the project by our engineering director, Laura Jean, and he gave us the Stanford Pupper, which had open source software, hardware, and CAD design, but it didn't really match up with a lot of the aesthetic, mechanical and hardware software capabilities that we had in mind when we first thought of the project. And that's how we found the Petzoid project, which is pictured over here on the right, which definitely lined up a lot more with what we were, initially inspired by and thinking of. However, it was closed source. And so we basically had to build the entire project from scratch, both hardware, software, and CAD design wise. But yeah, let's go ahead and jump right into meet the team. So I'm Cameron Sherry. I'm the team lead for this project. My major is computer science. I'm a third year at UCI, and my fun fact is that I am the fun fact. All right, moving on.
Hello, my name is Rani Kantbagi. I am a chemical engineering major, third year. My fun fact is that I folded 1,000 crates.
Hi, my name is Allison Eiler. My pronouns are she, her, hers. I'm a third year mechanical engineering major, and my fun fact is that I've watched Grey's Anatomy 7 times total.
I'm Sam, pronouns are she, her, hers. I'm a third year math major, and a fun fact about me would have to be that I have a whole wall in my room dedicated to local art pieces.
Hello, my name is Ian Gonzalez. I'm a mechanical engineer, my 4th year, and my fun fact is that I am the social director for Fusion.
So Olivia couldn't make it, but she's a first year computer science major, and her fun fact is that she's allergic to nuts.
Hi, my name is Sean Manili. I'm a third year mechanical engineering major, and my fun fact is I play electric guitar in my free time. So now we're just going to go into more on our budget and planning.
Here we have our bill of materials where everything is recorded and categorized for the sake of organization. Next slide. And as you can see, the entire project resulted in a total cost of $487.32. I'll pass it on to Ian for the Gantt chart.
This is our Gantt chart. What a Gantt chart is basically a visual representation of what we did throughout the school year. Yeah, and I'll pass it on to Ali for, yeah.
Our overall goal was to make a low-cost pupper that can easily be replicated by small groups. Our main goal for fall was to solidify a design. Our main goal for winter is to finish that design and then establish a code base. And then in spring, our main goal is to rapid prototype and begin the competition. I'm going to pass it on to Sean to discuss design and assembly.
So the software that we use to design the RoboPupper is Onshape. It's an online CAD software program that allowed us to collaborate in real time. And for inspiration for the parts, we utilized the table as our reference.
The first part of our design and assembly is the leg and the thigh. We designed the leg like the Petroid to be sturdier with a custom cutout that is a lightning bolt. And for the thigh, we used a shape of a bone, which utilizes 2 parts to support the servo arms and the springs when it moves. On the next slide, it shows a GIF of how our leg and thigh work together and how the spring and the servo arm is encased in the thigh. I'm going to pass it on to Rainiel so he can discuss the body and the head.
So then, yeah, we moved on to the head and the body. The head was completely redesigned. As you can see from the first picture, it wasn't the prettiest, but we made it through to really keep design at the end. Our features heavily relied on interlocking pieces, as you can see from the gaps. We had to make sure that all our pieces fit together, and we did not rely mostly on screws. And then our body, we used dimensional analysis for the ratio and to estimate the size, as like using like the pi and the battery pack and stuff like that. So I'm gonna pass it on to Cameron to talk about the software and hardware part.
Right, so software and hardware, we use a lot of different technologies, some of the most notable being Flash for our backend and the Google Cloud API for our natural language processing for the voice control. And so our hardware stack basically consisted of a web app, which would send wireless commands to the Raspberry Pi, which would then send serial commands to the NI board. And then the NI board would initiate all those commands using its Arduino code, which take input from the motion processor, which would power about 11 servos directly powered by 2 high voltage, high capacity batteries in serial. And then we can also upload code through the FTDI port right there at the bottom over here. And this is just kind of a brief lookup of our web app. And you can see here, it recognizes the voice command, matches it with something in the command dictionary, and then you can send that command. You can also just click a button to send something from the command dictionary, or you can manually type in a command, which then gets sent over Wi-Fi. And you can send a command from any device, anywhere on the network to the robot, which can be also anywhere on the network. So it's pretty cool. Works from a pretty long distance. So I'm gonna go ahead and pass that off to Ian.
With all the teams, with all the parts successfully designed, we now started prototyping. Some issues we initially had were that the head pieces did not fully interlock, as well as the NI board not really fitting in properly. So we had to make some edits with that. However, as a team, next slide, we overcame these problems, and eventually our issues ended up just being screwing struggles, as well as maybe even wire management. Next slide. After many months of struggles and teamwork, this is our final prototype. I believe as a team, we are very proud of this, and thank you for watching. Yeah.
All right, so I know we all sounded really dead in that presentation. That's because we were really dead in that presentation. I think we recorded it like 11 p.m. at night, and we had to record it like 5 times because it was initially like almost 15 minutes alone, and we cut out a lot of stuff. But yeah, just gonna get right into this, the last video. Can you guys see my screen? Is it still working?
Yeah, you're good.
Okay.
Okay, here we go. Focus. Speed. I am speed. 1 winner. 42 losers. I eat losers for breakfast. Breakfast? Maybe I should have had breakfast. A little brekkie could be good for me. No, stay focused. Speed. I'm faster than fast, quicker than quick. I am lightning.
Hey, Langdon, you ready?
Oh yeah, lightning's ready.
You silly goose. You're so silly.
Guys, my name is Cameron Sherry, and I'm the team lead of Team Bolt. Keep it a secret. Anyway, we work hard over here. Yo, damn, is that a robot? Damn, that's so cool. Anyway, we work hard, bro. Damn, let's go. Anyway, this is my vid, so peace.
Does Cameron hate me?
I hate this team.
I need a job.
Honestly, it's not about the destination. It's about all the friendships you've made along the way.
Say the command.
I don't want to. Okay. Push up.
All right, there you go. That's our presentation, our video. Just to clarify, it was a little difficult to see in the video, but our dog weighs about 1 pound and it was lifting quite a few times its own weight. So that was what we were trying to explain there. But yeah, so that's everything. Are there any questions or anything from anybody?
No questions, please. All right. Thank you, teams, for presenting. Wow, that was so good. You guys did it. You got robot dogs. Nice, nice. Okay. So we might be running a little bit over time, but we're gonna try to do this quick. Please bear with me. We still gotta see who the winners are. So let me go share my screen here. Okay. Whoop. Okay. So now it's your time to vote. We're gonna let the audience, you guys, vote for your favorite doggos. Again, the QR code and the link is on the slide. If someone could send the link. Yes, thank you, Alfredo. So I will give you guys like 2 to 5 minutes to vote. Then after that, I'm gonna close the form, and I'm also gonna need some time to like calculate all the points together based on the form. So again, please bear with us. So yeah, I guess in the meantime, while everyone else is voting, by the way, I would honors to some. To make this fair, I would like the teams to not vote for your own teams, or like to not have the teams vote in general. You know, just to make it fair. But please vote while you can. I guess in the meantime, if you guys have any questions for the teams, please ask for them now. Sorry, I also have a list of questions of myself, so I can ask them too. Oh yeah, Regina asked, how did y'all decide on your team names?
For Team Bolt, we were kind of inspired by the dog Bolt, or the movie Bolt. That's kind of how we came up with ours.
I can go for us. So one day we had our usual weekly Sunday meeting and we were trying to decide a team name. So we were all just looking at pictures of dogs, and I saw a golden retriever and I was like, I want to do a play on words somehow. So then I came up with golden receiver. And I'm not sure who named it Gertrude, but it became Gertrude, the golden receiver.
I'll go for Fido. Oh,
so you can go.
Someone. Oh, okay. Sorry, but Fido basically is actually the Italian version of Hachiko. So shout out. Basically, just yeah.
My God,
it's basically just a loyal dog, you know. And we like replace some letters with numbers because we're edgy, you know. But I'll pass it off to Eliana.
Oh, well, to continue on to that, I don't know if you all know Hachiko, but there's a statue of him in Japan because he's such a loyal dog. When his owner passed away, unfortunately, Hachiko would always walk to the train station and wait there all day, waiting for his owner to come, which he never did because he passed, and that's kind of sad, but yeah, we love Hachiko.
All right, so the next question given by Nicholas, roughly how many lines of code was written? He is genuinely interested.
I think for Team Bolt, I'm checking right now. I think for the motion processing, I think it was we used an open source project and then modified it a little bit. So that was about 2,000 lines of code in Arduino for our motion processing. And then for our command server, I think in total that was about 300 lines of code. So we had some code running, some Python code running using Python Flask. We had a front end, that's the web app. And then we also had a command server running on Raspberry OS, and we had to set up Linux services in order to make sure that things were booting up properly. And I think that was another about 100 lines of code there too, just to receive the commands, translate them to serial commands over the GPIO so that the Arduino could receive it, because the Raspberry Pi would sit on top of the Arduino and then would be powered and receive and send data directly through those GPIO pins.
I can go for Fido's. I'm not gonna lie, it was quite, I'd say about like several 100 lines of code, but I was so fixated on like a specific aspect of the code that I honestly don't remember. I'm having like flashbacks of each lines, and I'm like tripping out right now. But yeah, but it all can be written in the master string. So yeah, that's cool.
For our team, since we used that Maestro control center thing, it really, I don't know if that even counts as code, but if you did see it, it was only like 20 lines. With the Python script that had the voice recognition, that was maybe 50 lines from me. The rest was from other sources, like the example code for voice recognition that I used.
All right, the voting form is closed. I will be, please have some patience because I need some time to count all the scores. So keep going. Or actually, you could go off of this question. What are you most proud of about this project?
We got it done.
Yeah, I'm actually gonna go just because like I could go on for hours about how proud I am of my team and the fact that we actually got a working robot done in time, and everyone was just super talented and super dedicated to the project, and they really put in the time. And I'm really proud of my team and just how we were able to work together and learn and accomplish something. So yeah.
I'm gonna ditto what Kelby said. Yeah, it was just a very tremendous experience. Getting to know like really like-minded people, the hard work that was put in, that was the most impressive for me. Everybody came together. My team showed up all year. I'm so proud of you guys. You should give yourself a round of applause.
For me, I'm proud of the fact that we can do so much in so little time, because procrastination hits hard, But yes, thank you for my team for sticking with me till the very end. I know I can be a better team lead, but yes, thank you. I will try better in the future.
Yeah, I would like to give an actual response, but honestly, this entire like 3-quarter experience has been like a fever dream. There were a lot of highs and a lot of lows. There are a lot of rough spots where there's a lot of self-doubt. We just really didn't know what we were doing with the project, what we were doing as a team. But then we all stuck together, and we had some like really rich conversations that really helped us understand each other, understand what we wanted. And, I think by the end of it, like we're all good friends now. And I think what I'm most proud of is the fact that we all just stuck together through it. And I can say that I came out of here with some like lifelong friends. So really proud of my team, really proud of what we came up with. I think it looks great. So yeah.
Okay, so I believe we are done calculating. Just let me stop sharing my slides so there are no spoilers. Give me a minute. Just give me a minute. All right, one sec. Okay, I'm gonna share my screen. All right, here we go. And the winner is, can I get a drum roll, please? Yes, make noise. The winner is Team Bolt. Yes! Team Bolt won by a landslide. My goodness. I had to stop counting because it was pointless. But I'm actually pretty surprised, actually. But congratulations to all the teams and your hard work. You guys did a great job with your creations and your presentations. I'm gonna, we only have 6 minutes, but I'm gonna speed run this. So for your rewards, you get Benjamin, but in a form of a coupon card, gift card. So you get $100 for each team member in the winning team. You also get this trophy. That's just my reflection. It's not part of it, but here, if you look at my video, this is what it looks like, actually. It's a nice plaque, so we don't have one of those, actually, so you guys decide who wants to keep it. And also, you guys get free fidget spinners. So this is something we've been developing over the past year, and we're still making more, but for sure the winners are getting fidget spinners for free. Look, it's a Fusion logo. But there are rewards for all participants. Yes, for all teams. This isn't for nothing. For the first one, you get custom bowls. If you can see here, custom bowls with your team names, all 3D printed. And they get treats. So like treats like this, most patient, clumsy, loud pup. These are all catered to each team. So you each have like a different set of treats, but those will be given to you. You will also be getting the logos that you guys have. These custom logos will be made on stickers, and they will be delivered to you guys or distributed to you guys somehow. But yeah, those are for free. We also get miniature models of your robots. So we didn't have much time to like print all the miniatures, but here is an example of Team Hachiko's robot. I don't know if you can see it, but it's a very small model. It's actually quite a bit small that like some legs kind of snapped off, but I'll try to figure out how to make that work. But you guys are getting that, rest assured. Also, you got to keep your creations. Like everything you made, you got to keep, and it's up to you if you want to continue developing what you guys made. So congratulations. Also, you get more Fusion spinners. So as I said, we're still developing more. So we're not sure if we're going to give these all for free. We're not sure if we're going to give this out on time. So yeah, this is the whole set. You know, thank you for participating. You guys did good. And also, I know for some of your videos, you said that your dogs are for sale, but I assume they actually are not, because those are actually kind of expensive. And so, yeah, I also want to have a special thanks for COP. We actually have a trophy for you for being our #1 advisor. Here's that thumbs up from before. Yes, thank you. Make some noise. And yeah, you've been our advisor for 2 years so far, and we look forward to having you for more. I also want to give a special thanks to FSI and P Council for being a good resource for this project and for our club in general. And so, yeah, so I want to note, so these are closing remarks now, just to warn you. So the teams didn't use the guides that we provided as much as we thought. Most of them had to develop their own code, actually. So a lot of their creations were actually crazy creative. This is they really use their creative freedom to like make this work. And like, God, it's so exciting to see it all manifest after so long. It's been a stressful year, and trust me, like all the teams struggled a lot. And COVID made it that much harder to figure out how this would actually be built, how this event would even happen. But that just makes it that much more satisfying to finish. And yes, there was a winner for this competition, but I want to remind you that this doesn't necessarily mean that they did the most work. There were specifications of this competition that we had to abide by, and Team Bolt completed the most that we asked for. But all the teams did a crazy amount of work, and I'm surprised that they're still sane. And I give props to all of you, pretty much. You guys are done. You're free. You don't have to stress about this anymore. Yes. Are you guys celebrating? I don't hear anything. Yes. Yes.
Woohoo!
Right. Yeah.
Let's go.
Yeah. I guess for now we're just gonna have a short break, a really quick 2-minute break before our next event, the industry panel. The link will be sent in the chat, but once again, thank you all for participating, not just the team members and the FSI and P Council and COP, but also you guys for attending this event. It really means a lot to us. This has been in the works for a year now, so I'm just glad it's over now. But there is still more to come with the next 2 events.